Hi everyone, this is Jason, producer of Data and Biotech. Before we get started, I wanted to let you know about our latest white paper. It's a comprehensive guide to implementing machine learning models in biotech manufacturing. It's a complete overview of all the potential problems of ML adoption and, more importantly, how to solve them. To download it, simply visit connect.cordine.com/biotech-ML. We've also dropped the link in the show notes of this episode. Okay, let's get into it. Welcome to Data in Biotech, a podcast from Cordine where we explore how companies leverage data to drive innovation in life sciences. Every 2 weeks, we sit down with an expert from the world of biotech to understand how they're using data science to solve technical challenges, streamline operations, and further innovation in their business. This week, we sat down with Brendan McCorkle, CEO of SciNote, a cloud-based ELN with lab inventory, compliance, and team management tools. During the interview, we discussed the importance of balancing flexibility and structure in the ELN space to accommodate the varying needs and workflows of different stakeholders, such as R&D scientists, process engineers, and data analysts. We also discussed the challenges and importance of data sharing and collaboration in R&D biotech organizations, striking the balance between flexibility and constraints in implementing ELNs, as well as the future of ELNs and the incorporation of machine learning and AI technologies. Here we go.
Brendan McCorkle, welcome to the Data and Biotech podcast.
Thanks, Ross. Thanks for having me.
Awesome. Well, just to kick us off, can you give us a brief overview of your career to date and what brought you here?
So I came to entrepreneurship, I think, the scenic route, which is part of why it's hard. Like a lot of my peers, I think I tried about everything else imaginable before ending here. So I went to school to play baseball, not to do school. I ended with a psych degree, was a paramedic for a while. And it took me a minute to realize that the thread between all of these, and including being a terrible employee at a lot of these roles, was that I was deeply unsatisfied by the status quo, thought I was smarter than everyone else around me, and thought I could do anything about it as an entry-level employee. So in hindsight, it took me a minute to put together what the shape really was, but I think this screams entrepreneur. So I went to grad school to join my friends who are all software engineers from a former athlete psych degree. It's actually tricky to work for big tech, and got a degree in engineering management. This coincided with the first financial crisis. And so I found myself educated the right way and no longer owing my employer at the time a few years afterwards. And no one was hiring. So I started a job. If I wasn't going to have a job, I might as well start one. And I started a company. I guess the rest is history, but that was the first of a few. And all of my companies have had a little bit of what I call a buy us for us product thesis. So we built developer tooling, sort of by developers for developers. I helped spin out a healthcare company that from Penn, that was by clinicians for clinicians. And most recently, before SciNote, turned around a consultancy, but they had a small edtech product, which was by teachers for teachers. And so, of course, now SciNote was sort of by scientists for scientists. I seem to have a thing. And this by us for us foundation is near and dear. But now that I've done it a few times, I guess that's what I do.
For sure. So, tell us about SciNote. What's the company's mission and how does it go about accomplishing it?
So SciNote was started to improve science, which is sort of wonderfully ambitious, right? But specifically to take a piece of the scientific process, which hasn't changed since Marie Curie, and taking notes on a piece of paper is still the magic backbone of the lab hundreds of years later, which is staggering. And other parts of the world have moved into technology as a way to stop the data loss from losing that notebook or having the notebook get damaged or facilitating the collaboration between maybe you and I as peers in a lab. It's hard to do that on a piece of paper. It's really an individual unit of work. And so science has gotten bigger, but the technology powering science hasn't. So this is really the nugget here. SciNote's mission is to preserve the knowledge of science by eliminating places where it gets lost first, and then the facilitation of new knowledge generation.
I mean, just hearing you talk about it, I have a biased view here because I come from sort of a data perspective, but all of these problems to me sound like problems of having all of the data in a way that's available, in a way that's integrated, where you have metadata about the experiments that are being run and sort of the insights that are being generated, and all of that connects to the metadata that exists about the inventory that you're using.
Yeah, you just mentioned 2 of the 4 FAIR letters in FAIR standards, right? And the I is interoperable, and very few vendors have an API, right? The A is accessible, and it's funny, the F and the A kind of blend together. I actually just gave a talk where we talked about the air gap. So cheekily saying that the A, I, and R of FAIR, that we need to mind this air gap because it's very easy for vendors to actually make all 3 of those worse instead of better. So there's a little bit, if we're as an industry trying to move towards fair data, we have to be cognizant of the choices that we make in our product and our distribution that make them better or worse. We don't want anybody doing the real answer. The easiest findable, the easiest accessible is just plain text on the internet. Well, this is horrifying when it comes to data security. So maybe we shouldn't do that. So what are we going to do instead, right? It's like one extreme is just to put it in plain text on the internet. No way. The other extreme is this walled garden where it's at least secure and it can be findable if you use ours. And then it's really tricky to balance in the middle. And I think that this is a place where maybe we're well-intentioned. I hope we're well-intentioned for what it's worth. Maybe we're stubborn or maybe both. But it looks from the outside like other folks in the market have looked at this piece and go, wow, it's really hard to balance these two. And then they've chosen to leave the difficulty of the solution space because it's hard. And we've been stubborn enough to say, the market is telling us we can't leave this point of difficulty. Our users are telling us you have to support our difficulty, and we love them, but some of this balancing is really tricky. And so we've held on to that balance and said, too bad that it's hard. We're going to still support this level of difficulty because we have to.
I think I want to spend a little bit of time on the user perspective. It sort of leads to this because one of the challenges is that in this integrated data ecosystem, you've also got stakeholder groups across the organization that have different sets of needs from the data that these systems are throwing off and different sets of questions that they want to ask about what's being captured in a platform like SciNote. So could you walk us through what those stakeholder groups are and what each group kind of typically cares about in terms of a platform like SciNote?
Sure. So I think the easiest unit for us to talk about is the scientist at the bench. This is where we were started, and it's sort of the beginning of this journey. And it's also the introduction of tension starts here, because especially in R&D, and we are disproportionately powering R&D scientists as opposed to any particular flavor of scientist, there is a direct correlation between the amount of flexibility, if you look at it as increasing flexibility and increasing research and better science, and constriction and the reduction of the space to be creative. So there's push towards being as flexible as possible. And I think this is maybe the first philosophical divide in the market, is whether you say, oh, because R&D, especially the R of R&D, because of novel science, research, testing new things, this is the hardest thing to structure because we don't know yet. So let's let the scientist have as much flexibility as possible. And this is maybe, the ultimate pure ELN is just literally a blank piece of paper that's digital, right? It's paper on glass. Do whatever. You can do anything you want to. It could be a picture, take a picture of a drawing. It's just totally unbounded. Now, this is the biggest stuff of nightmares down the line for the data team or the informaticists, who might be one of the other groups. But at least for the R&D scientist, this is maybe the promised land. Somewhere between starting to add structure to this and closing it all of the way down, which is maybe the most important for manufacturing in biotech and pharma. We actually want it to be the same way every time. You lose some of the creativity. And I think that this is like I said, we have decided that ultimate flexibility actually isn't worth the pain that it causes further down the line. So we try very hard to be as flexible as possible, as opposed to as flexible as you could be. These are very nearby ideas, but they're not the same. So we have peers who have certainly chosen ultimate flexibility, and we have peers who have chosen no flexibility. And those sort of self-sort into the R of R&D and manufacturing. So this is a big philosophical divide. We are trying to balance these two, which I think allows us to actually tell a story about our R and D, and really learning that D, which is development, is underserved in our market, because it gets lumped together. When people say this is a tool for R&D, they really mean R. They don't mean R&D. And so this is where I think we're starting to get pulled into a new part of the world where we actually start having stakeholders that need some different stuff. So a great example of this might be someone who's in a big biotech. They're at a big pharma company, and they are responsible for starting to do the transition from R to M of manufacturing. And so they are testing whether they can actually do something at scale. So now there's some structure, because it's really important to see if it works and to track the dependencies, but we're still looping. So we still can't do fully structured yet. Also, it's biology, so we care about lineage. And maybe the mini soapbox here, inventories are not inventories. And I think this is one of the dangers of the conversation between ELN and LIMS. If you're doing cell-based bio work, you care about lineage in your inventory. It's really hard to do nonlinear stuff, and to do lineage is a good example of nonlinear stuff in a table. So we have to have this space here, and we have to be able to take totally unstructured work from the R, whether that's us or another system or paper. We have to be able to support somebody who's starting to care about structure. And this is for the scientist still, maybe a process engineer, and we're moving towards the D of R&D. Or now we're at a big enough organization where they have a data scientist or an informaticist, and maybe they want to do some analysis on the work. And here's where it gets crazy. When we don't pass the context of the science to the person doing the analysis and then loop the analysis back to the scientist, we've taken all of the learnings from other industries like Toyota and auto manufacturing, where they've said, look, the way is to allow people on the floor. These are not engineers. These are maybe lab technicians, might be a proxy for it. They didn't design the experiment. They didn't make the engine. They can pull the cord and say, it's off today. This is an explicit endorsement that there is context at the floor that matters. But if we don't pass the context from the bench into the business unit, we're basically saying Toyota's wrong and that the context on the floor doesn't matter, because we're passing the data out without the context, and then someone's doing analysis on it, and we're telling the person doing the analysis that the data collected by the person with context doesn't matter, or they can't have it, which is even worse if it's not connected. And then if we don't pass it back, we're telling the person at the bench that the analysis isn't important because they don't need to know that it happened or what the output was. And can you imagine someone at the bench might be going, it's off today. There's waste there. There's maybe an experiment line of reasoning that should be shut down, or this is working better than we thought. We're on to something, R&D, or in the bioprocess, that just means maybe we found an even more efficient way to do this than we were challenged to do. These are both great to the business of science. And we just cut this line of collaboration by not allowing the data to flow in both directions. So this is tricky because it might be passing unstructured data to somebody who wants it to be structured, but not willing to lean into this problem space, nets saying a whole cluster of terrible things like, no, you can't have that information. No, we don't think your opinion is important. Yikes, right? So these are places where we try to spend a lot of time to make sure these can be loops and can actually have a feedback cycle that allows a scientist to plan their experiment, run it, them or someone else to analysis, and then let that be a feedback back into the next one. You can probably hear my indignation. Like, this is how science is taught. This is how science is done in the lab, in an academic lab, in a federal lab. It doesn't matter. That makes me want to say, like, we must be bringing them a solution, not we should. We must be bringing them a solution that maps to this world. And so when people don't support nonlinear workflows, when they don't support lineage and inventories, this is like what? How dare you even, right? How dare you do this? Like, that's not serving science. The flip side of that coin is if you aren't serving that shape, you're making the shape worse. And we've started to say, maybe this is actually making science worse instead of better. This is the opposite of success in a market. This should lead to lower revenue. This is damaging science. This is damaging innovation. Oh boy, we should be real intentioned about the choices we make in this problem space.
Yeah, I mean, I love what you're talking about in terms of moving from people who think of R&D as research only and moving from research into development, and sort of an ELM platform that integrates across the different aspects of a biotech data ecosystem needs to sort of lead in that direction. I wonder if you can provide sort of an example or some more concrete insight into like what the interfaces look like for the research scientist versus people who are further up the line in bioprocessing or development, and like how they interact with the system differently in order to accomplish their different goals.
Yeah, and you can slice the first one a bunch of different ways, and I think this is part of the challenge as a software vendor is you can bucket high level stuff, like maybe a biologist doesn't want to do the same kind of workflow that a chemist wants to, and there might be some fun conversation just there for someday. But even biologists in lab A and biologists in lab B may have some different workflows. So there's a balancing act here too, where everything that we've been talking about so far, plus now you have this huge variance sort of intra-company or even inter-company, even between different locations or collaboration between public and private set of companies. You have to cast the net wide enough if you're trying to get to this sort of invisible software goal where when somebody goes to reach for the tool, right? I always picture like the auto mechanic, right? On that sliding under the car and like just reaching their arm out and like the tool they need next is there. They can't see it. They're under the car. This is the way. So you might be reaching for a wrench or some other thing or a hammer or a drill. And if I were working on the car, I might be reaching for something else first. So one piece is allowing people to enter as many ways as they can. And so there's a breadth answer here, which sets up a downstream wackiness. But if you are at the bench and you're entering a value in, some people might be in a clean room. They can't write it down. Maybe they need to talk into the system. Maybe you have a really old scale and it's not a digital in any form. Maybe you're actually taking a picture with your phone of the output of the scale. Or maybe there's a member in your team who refuses to give up a paper. You might be taking a picture of a paper notebook, and then this is now an input into it. But at least you're capturing any record of this. You're able to tag it, have metadata at all. You know where it was, who it was, when it was. These are all moving towards some sort of data truth. So this is one step, actually casting the net wide enough to do it. And then I sort of stole my own thunder by saying metadata. There's a little bit of post-processing to do in that just from the picture to now it's in the system of truth. And being able to know who, when, where, what is it? Can we get fancy and OCR something that's a picture? So now it actually is in the data fields too. This is sort of what I'm talking about as sort of the responsibility of the vendor. So if you entered it manually, you might want to enter it into an open text field. Someone else might want to upload a Word document of it. Someone else might want to take a picture of it. If those can end as the same thing to the set of data, we're not offending the people downstream. So this is sort of the goal. So the vector you mentioned might be different. It might be OCRing if it's a PDF. It might just be normalizing the data if it's an open text field and a document. But trying to let the entry of the data be as open as possible, but starting to actually trend the same stuff to the same stuff, so that when we pass it to somebody doing analysis, we don't have the equivalent of an Excel file that has 19 different headers. So that, t-test with both capital T's and no space, t-test with a little on this side, the little t on that side, the opposite, maybe a space before the hyphen, maybe no hyphen. These are all a t-test. I just pick on this one because everybody knows what a t-test is. This data scientist has some work to do if they're actually given a pile of data that includes 19 versions of t-test instead of one. This level of constriction does not change the ability of the scientist to do scientist. This is why I like this example. It's not going to change whether they use different amounts of acetone or acetone at all, to pick on acetone. It's still a t-test. We know all of those are t-tests. And if this is run regularly, the software can know this too. Maybe there's a little bit of machine learning here, but it's not magic. We're not talking AI. This is low-level technology lift to normalize a data set so that somebody else doesn't have to. And I think that's where this bridge happens. And one such example, the other is with a photo, having metadata, automatically applying metadata, starting to do things like, you ran this protocol before. Would you like to again? Did we just save you 5 clicks and 3 data entry fields? Okay. Bob and Sarah, someone wants to work off of a checklist and the other person wants to work off of a static list or a picture. If we support both of those, we have 2 happy users. It's relatively low lift to be able to have that in the UI as well. So to your question it is a juggling act, but it's to allow people to set up relatively flexible UI elements to mirror relatively flexible workflows so that when they're moving through the workflow, they don't feel like we're making them think about the steps in the workflow. And that isn't the same for you, that isn't the same for me. So we have to support a bunch of different entry points and exit points.
Yeah. So, it strikes me that, there are sort of myriad problems to solve across myriad stakeholder groups. And then also, you mentioned up front, sort of not constraining the creativity of the science. Like you're trying to enable this, you're trying to enable the scientist. But I can imagine that sort of at an organizational level, at a laboratory management level, you want to apply some sort of constraint. So how does that work?
Yeah, it's like a stand-up routine, right? I can make fun of myself. So ELN vendors are making it worse unless we do something differently. I really feel this. So, and this is the rub. If we go to ultimate flexibility, we are making data less fair. We're making it harder to achieve fair standards. We're upsetting people downstream for the data, but maybe up the hierarchy also, right? It's really cliche, but software vendors talk about how like giving a dashboard to management sometimes is the whole thing. But if you don't have really good data fidelity and interactivity between these pieces, you might not even be able to populate a dashboard because it's that much of a mess. So it's like you probably, the scientist wants to buy the software because they want to use it to do their job, but they have to convince their boss or their budget or procurement. And this is sort of part of the magic of enterprise sales motions is what's the view for the boss, the head of research operations, the informaticist, which is a very important and highly educated, hard to employ individual in our space right now. They should be happy with it too. So what do they see? Do they like what they see? Is it actually tucking nicely into their workflows, which might be super different? They might want to look across the whole portfolio of R&D. They don't care about the protocol inside that experiment. They want to look at machine utilization or scientist utilization, or is anybody in the lab? They said they would be. Why did we use 3 times as much acetone as we used to for this? Are we doing a new experiment? Or did something move that we got to go look into? This is somebody's job, and they have to be able to take that zoomed out view. So yeah, it's tough to see this fully stitched together view of the data in the lab. And so the first step, I don't know, there's other things in the world where they say the first step is realizing you have a problem, but it's similar to this, where the first step is realizing the consequence of not realizing that all of these fronts are a place for data to get lost or for context to get lost, which makes integration harder. At least 2 of the letters in fair data get harder real fast without thinking about this problem space.
How do sort of executive stakeholders at companies who work with SciNote evaluate whether the system is doing what they need it to do?
It's always an interesting question because I think we want this answer to be different than it is. I think the warm and fuzzy one is that the executives at these companies really want their scientists to be happy. And so they say, okay, scientists, use whichever tool you would like to because we love you and respect you. And you tell us what you should use, not the other way around. Unfortunately, this is not always how it works. It is in some places. And there's certainly employers with very high eNPS scores, and it's partly because they do what I just said. Also, there are places that are, more interested in the velocity of things through their R&D pipeline. And so they're aware of the cost of loss. And I think that the business case comes as sort of a blend of efficiency and loss interference, I guess, loss reduction. This is a very strong proxy to in healthcare, where if you can say, oh, well, if our handoffs are better between the outgoing doctor in a shift and the oncoming doctor in a shift, there will be better outcomes for the patient, but maybe even more importantly, fewer adverse effects. So this is more of the operational, and the business case is actually the lowering of the bad stuff. So fewer false positives to go into the R&D pipeline. The longer that false positive goes forward, the more painful it's going to be to take something out of your R&D pipeline. Faster stuff through the goose, less time spent on non-science by scientists. So this is where those pieces of the Venn diagram do actually overlap. The scientist might say, I love using this, but what they're saying includes the space of, wow, we've seen people spend 9 hours less a week on non-science because of this unification we're talking about. Some of these places have 1,000 scientists, 9,000 hours of non-science. We're talking like 250 FTEs worth of crap that's now not crap. And they can either do a little bit less work and be happier. Maybe they can do more experiments per time. The individual might say, hey, my job just got easier. But the business might say, you can do more now or waste less of our time resource. We could have a team that is staffed 80% of what it used to be with the same output. There's lots of cool stuff you can do with 250 FTEs worth of time every single week. If you're in the business of pharma or biotech, this is really powerful. So the scientist might say, hey, I love this, but the boss is going, I love the impact of this reduction. And that's just time. That 250 FTEs is just time. This isn't the reduction of replicated studies. This isn't the higher fidelity data into our analysis machine. This isn't the faster things through the R&D pipeline, less false positives, which is kind of that rework or adverse effects proxy for me. These all get more science done. They get better science done. They get less wasted time to the business. That's less wasted money, faster velocity. They're in a competitive space. If I can get my stuff through the goose 10% faster than my peer, maybe I show up first and I have an advantage. This is a really big deal.
Yeah, that makes a lot of sense. So, from a data team perspective, what are sort of the workflows that you see in practice in terms of how data teams integrate with SciNote, and how does SciNote support those teams?
Yeah, this is a really interesting question because you might not be surprised to know that this is a little bit of a work in progress, because a lot of times we don't see this workflow because they aren't connected well. So I can give some anecdotes. So we have a customer, Gatehouse Bio. They are uncommon historically, but I think becoming more common in that they have biologists and microbiologists and engineers and data people. So they are a proper, more modern organization. This is not just a scientist in a lab notebook. So they have internal resources who are frustrated, and they're a small enough company that, that their peers are frustrated with each other because it's a relatively small company, very cool company, but this isn't 1,000 scientists, right? This is much more like 10 or 100 than 1,000. So small enough that you kind of know everyone else on the team, which maybe almost makes it more offensive when you're doing things that bother your teammates. So the data team has this t-test problem comes from this use case. I talk about it because their data team is like, we need to have an ELN because our scientists need to be aligned and we need to be able to collaborate, and God help us all with the stuff that they can put in there. Can we put bounds there? And so the analysis of the data is then maybe even more complicated because they do some really high throughput, high resolution microscopy as part of their step. And so they have a machine that's generating petabytes of data every day, which is staggering. I think, most companies talk about big data and they don't really have big data problem. They just have bigger than Excel problems, which means they should be entering the world of software at all, but they have not entered the world of big data. These guys, this is proper petabytes a day. This is hard to do over the internet. So what are you going to do? Their vendor has a special set of software. So they actually, part of the solution is acknowledging that's not the right thing to do in the ELN. It would be putting a square peg into a round hole. But now we have another player. So this shape that we're talking has another border where people at the company need to access those images, access them quickly. They need to end up somewhere, whether it's locally or not. And it's, not trivial to send that much data over the wire every day. And then other people in the team need to something. So is it a low res snapshot of that picture so there's a log of it? Or is it just actually, a link to the other vendor's site? This is a really good example of playing nicely with other parts of the workflow. We don't need to. What I'm saying is we don't need to know the workflow of that data vendor because their use case has already said, hey, the system of record is over here. For this part of our lab, it came with the machine. It's powered by the vendor. We have somebody to call up to say it's not working. We just need to make sure that you guys are aware it even happened. Very light. This isn't petabytes of data. This is kilobytes of data, maybe even. It's very light. It doesn't maybe even need to be a picture. Just the line, images were run today. That might be enough for the rest of their team. So I layer this on there because part of the magic is you're asking about these workflows. We have to support some of them even when we don't know where they are. And when the systems aren't flowing perfectly together, we don't know where they are. So that changes our answer rather from one of perfect context of what these workflows are to preparing for those workflows. And I think this is sort of the state of the market right now, is that so much of the conversations about AI, ML, even informatics and data work is preparing the stuff for that stuff before we're even doing that stuff. And so we should do this again next year when the preparation is done. Maybe we actually get a little closer to what these workflows are. But what we're running into is the gap between the bench workflow and the data workflow, and collectively working on preparing for the informaticists workflow. And this work is typically done somewhere else in another system and not looped back into the ELN. So this is only just starting. So you're probably catching us at peak. It's coming. And least I can answer that question with the highest fidelity. But that in itself is the problem.
Yeah, that's great. And I think this sort of brings me to another question, which is you mentioned integrating with the microscopy platform that they're using to generate petabytes of data and get sort of the URLs out of that system and into SciNote. What are some of the other integration points that you view as crucial for bringing all of that R&D work into the SciNote?
So cheekily earlier, I talked about, a fictitious Pfizer, where they have, 15 LIMS and 7 ELNs and what have you. But we can talk about real. Agilent, for example, is one that we talk about a lot. This is, they have their own ELN. They built their own, and then they also brought us in. So the world where there's only one, this is one of those reasons why I'm like, there is no world where there's only one. So if I step back just one step and look at this, I think there's sort of a couple categories of systems that we should talk about. And ELNs are one of them. I think we are sort of human entered data. human-generated data. I think there's also system-generated data and machine-generated data. So when I talk about the other ELNs and the other LIMS, I'm talking about other software, right? And machine-generated, like that scale or the microscopy, there are a lot of machines in the lab, and some of them, maybe some of the more modern ones, are or have the ability to be sort of data-enabled. This was part of our origin story. Why we built our company was to try to combine at least two of these three. We think all three of these pull into a place, and then that place needs to talk to legacy data. It needs to talk to other vendors. So there's a whole suite of entities that could either consume our API or vice versa. And those are probably the largest buckets are other places where it's human generated data, system generated data, machine generated data. Then there's the downstream. This is towards the data scientist, towards the informaticist, that they probably have a BI tool. They're doing work wherever the hell, and they are doing their data pipelines in a system. And so they need to ingest it into that system and then export it back. Even inside human entered data, we have people who are doing some work in Excel and they want to pull that in, or they're doing something in Google Docs and they want to pull it in. Take a picture of the scale. We pick on this a lot because the scale is like almost trivially small. This is not the cost or the size or the headache of the machine doing a petabyte of microscopy. This is just the scale. We could not let them enter a negative weight. That's never going to happen. We could not let them enter a negative distance. That's never going to happen. Another example like that t-test example where we pick on, that's a pretty small change, but that messes up the data downstream really big time. You start running an average on weights, but you let a negative number in. Oh boy, right? No more confidence in anything that comes out. Someone's got to go back and chase that all the way to higher fidelity data. And when you start getting into the business, you start getting into there are systems for scheduling machines or doing analysis on utilization. Maybe you start getting into the closer you get to larger business and or manufacturing, you now start QA and QC start showing up. They have systems that they use. Maybe they're savvy and they're already using a company like Animate. So they have an SDMS, they have a data management platform. We're also sort of a data management platform. And so where's this blurry boundary? Hey, it's cool. We can use both, but we have to then mutually talk about using both, which if everybody is friendly is a beautiful thing. But so we sort of have integrations down into other pieces of software, over into other pieces of machinery, up, I guess, to keep this analogy going, into other people. And then moving to the right, if I were to draw this on a whiteboard, is the business and all of the systems. Maybe they have an accounting system that needs to get pulled in because that's where they track the acetone or getting more of it, right? A quality system, I talked about breaking it or having it stolen. Okay, maybe those go to quality, not to something else. Maybe it's a fully validated lab. So now they actually have to track IQs and OQs and the actual validation of the system. Did anything I just mentioned change? Oh shit, we got to go in and now make sure we document that it changed and revalidated the whole thing. We haven't even talked about this axis at all today. In validated labs, you now have another axis of, God help us, we can't do anything quickly or rationally because all of the processes are validated too. So now we have to do everything we just talked about, not like a modern software company. We have to do it like a big, slow NASA kind of, you can't make a change because this thing's 100 million miles away. Too bad. It's going to take 10 minutes for your instruction to get there at best. I hope it works. I hope it has default systems. It's kind of like this. No, we're going to do one release a year because validation. Ooh, how confident are we about bugs and other places where things could happen? We better be damn sure that this works, and we have to sort of respect the validation of our customers. So this is maybe another place that we have to integrate with. This is an integration, but it's a process integration. It's a people integration, if that's a thing, where if the lab is validated, we have to act like it, is what I'm trying to say. And this is another front for stuff to get really frothy. If we pushed a change and didn't tell them, that everybody's world would be pain. So we have to be able to support this too.
What advice do you have for R&D organizations or biotech companies more broadly who are considering implementing ELNs as a category or SciNote in particular in their workflows?
Yeah, this is a really good question. I think it's really important that someone making this decision hears from someone from my side of the table. Do not accept the answer that it can be all us. This is hypocrisy at best, hubris at worst. It's not true. It's just not true. And there's a profound set of motivation economically for a software vendor to say this as part of their sales cycle. But I think there is responsibility for us to say publicly no. But also, if you're shopping for one, this idea of meeting where you are, the responsibility is to let us show you how we connect to where you are. Don't let go of where you are. It's your way, not our way. I think this is really important. And to not be shy about the fact that you probably already have a system of record. So what we need to know from our side of the table as you're evaluating us is, what are you already considering as your system of record? What are the stakeholders that need to know? And I mean people, and I mean machines, and I mean software, and maybe also process, to pick on validated labs. What are those four pieces in their current state, and where are you trying to get them to go? You should be looking for movement from where you are to where you want to go. And it's probably more than one piece of software, and you probably already have some of them already. So don't succumb to our salespeople telling you otherwise, and push on these connection points of, how do I make sure I'm navigating with vendors who understand where we are right now, that are friendly with their peers and our own legacy pieces of software, and have the ability. You want to be looking for companies that have APIs. You want to be looking at companies who have ecosystems. These are signals of what I'm talking about. So if they have a vendor ecosystem, partner ecosystem rather, if they have an API, you have some confidence before even talking to any of us that they understand what I just said, which is that they can't go in alone and they can't change everything. And then just stay strong that, you know more about your stuff than you think you do. So don't just let us tell you how it's done. Please be looking for us to tell you how we can help as opposed to how we can change.
Awesome. What new needs do you see emerging for scientists or data teams or, biotech organizations more broadly in terms of their expectations from an ELN, either related to what you just said or unrelated?
I heard a talk last week where we spent a lot of time talking about the elimination of paper in the lab. And there was a gentleman running informatics at a large pharma company saying, we should start talking about the second phase of this journey towards digitization. Phase one is eliminate the paper. And I will say contentiously, maybe with a little bit of space, that I didn't say this first, but I do agree, is step two is the elimination of Excel. So this is going to be the thing that we introduce in successfully eliminating paper, is that we're introducing to bench scientists how software is done. And this is really fun because it's really cool, but it's also a little bit scary in that Excel is actually not the right tool for the job. It's the tool you all have been using, and this is the scary part. But just like paper, once upon a time, paper was the way you were doing it. And now, if we're right and the movement away from paper is right, paper is wrong in view against modern technology. Excel is really tricky to do securely. You step out of the machine, do some stuff, bring it back in. What changed? Who changed? I don't know. Did somebody leave? You asked me earlier about what the bosses care about. When Bob leaves our company and maybe doesn't give his laptop back, what data are we losing? Do we have access to all of his research? It was easy when all of the lab notebooks were locked up in a room down the hallway. At the very least, we knew he didn't leave with one of those. But now we think it's got to be digital. Cool. But what's the modern equivalent of, what was he working on? Can somebody else pick it up? Do we have access to it? Can we keep the machine running? Okay, cool. Same thing with Excel is tough. These data sets are getting bigger. The more we're moving towards AI and big data and real sink your teeth into a data analysis, the data sets are getting too big for Excel, which means you now need to have an interface into a database. Excel is one of those, but it's a very light one. I think people don't appreciate how light of a layer it is. And when you get into a lab where maybe you have 3 labs, 50 people in each lab, you have 1 million rows, at least a dozen columns, it's not Excel time anymore. And I don't think science has really truly internalized what the development side of the world has, which is lol Excel, right? So we have to, this is the next one to walk people through, is that actually it's okay to do your computation in a table that's not Excel or Google Sheets. It's okay to have an interface into a database. Maybe once we get step through okay, we can step into it's better. But first we got to get to okay. And I think this is right behind me, and all this rhetoric is that Excel starts getting in the crosshairs. That's coming.
Yeah. As a last question, what are your perspectives on incorporating machine learning and AI into the SciNote platform? Are there any future features or integrations planned?
Yeah. So I think another sort of reality, this Excel, and maybe we need to move into software, is that much of what the work is happening now is really more ML than AI. And so it's not as sexy to say that because AI is the new hotness, but there's some really powerful stuff that looks more like search suggestions like that protocol, hey, do you want to run that protocol again? This stuff is really cool and really impactful as a user of a piece of software, but it's really ML, not AI. So I think there is some really cool stuff happening in industry right now, and most of it's actually ML. So that's one sort of aside. We do some of this. For us, it's kind of advanced search is how we talk about, how do you look at a lab that has 5,000 protocols because they've been using it in a lab of consequence and for a long time, getting that more palatable for one scientist. The new scientist who comes on, looks at 5,000 and goes, what am I supposed to be doing today? This leans into ML is the antidote to this, not AI. And I think you probably already know my AI answer, which is we're preparing for AI. And a lot of the AI work is likely going to happen inside their business, not inside ours, with one exception. We actually did launch an AI tool a couple of years ago. So I think this is fun that AI is coming to fruit in the market now. We launched a feature called Manuscript Writer 3 years ago. It was not using ChatGPT, was, the glimmer of someone's eye still then. And we were taking all of the context we had about your work, and we could populate materials and methods, or the summary, or we could link to the research you were doing. And to my point about advanced search, maybe we connect this to suggesting other research that you should use that is similar to the work you are doing, are considering doing, or have done, instead of the popularity of it. And this is sort of search online, web ranking is based on popularity, not as much relevance, or at least it's relevance via popularity. So the ability to have the context of your actual work driving the results we show you, this is really interesting. This is AI and ML. So this is what that looks like in an ELN. In our ELN is taking some automated tasks off of you because of the context of the other pieces you're doing. Now, if we have another moment, the reason this didn't work is that the companies have 20 or 30 years of research. Maybe it's in PDFs, or it's in an actual notebook down the hallway locked in a room. That data's got to get into the LLM. That LLM also probably needs to not be ChatGPT because trade secrets. These are both enough tension to have stopped this a couple of years ago. So when I look forward, I think there's going to be, and I'll say LLM, probably more than one, because this is how markets work. There will be private friendly LLMs for biotech and life sciences where a Pfizer or Novartis would look at this and go, I could actually accept using this one. And it's not the current shape of ChatGPT because, oops, sharing data. So there's going to be maybe run locally or an industry-specific one that was, tailor-made for the security and trust constraints of biotech. This is nearby. Someone's probably working on it, and we don't even know. This is one of the pieces. And then the continued, interestingly, AI and ML power OCR solutions. So as this gets more accurate and cheaper, the shape of getting the data into a system at all gets lower. And so if both of those pieces play nicely, we revive Manuscript Writer, and now we can actually offer it as a service. It's accurate enough. It's auto-tagging the metadata. It's trusted, right? And so it's right there and not quite. So I think this is sort of that boundary we're watching, which is it time to revive Manuscript Writer or not with a private LLM? And that day is soon. Not today, but soon.
Well, Brendan, this has been a fascinating conversation and really appreciate you making the time. Thanks for coming on, and we'll plan to see you down the line.
Awesome. Thank you, Russ. Super appreciate your time and the opportunity to share my soapbox.
And that's it for this episode of Data in Biotech. If you enjoyed the episode, please subscribe, rate, or leave a review in your podcast platform of choice. See you next time.